tonight we are going to talk about servers, databases, big data, and clouds. And I am going to bring up topics that we've already covered in the other 3 sessions. We're going to see references to hardware. We're going to see references to software. We're going to see references to that machine code that we learned about in our 2nd session. And so all of that, we're kind of bringing all of the components of what we've looked at over the course of the last 3 sessions. We're going to see how that builds into some of these other concepts that we're discussing this evening. So let's go ahead, let's take a look at servers, databases, big data, and clouds. There. All right, what is a server? Servers are computers that provide data to other computers. So we saw that in our quiz questions. And most servers are accessed remotely using remote access software. That is true if you are utilizing a server through a web browser. It's true if you're utilizing a server in what I do, which requires me to be able to query language using SQL. We saw that in our quiz, or access the file system of the server. It's all done through software. There are special roles within data centers where people actually put their hands on the hardware. But most of the time when you're working on the server, even in a data center, you are accessing it through a terminal. So really no need to get in there and touch a server unless you have to work on the hardware itself. All right, what are the differences between a server and a personal computer? All right, because really servers are computers that provide data to other computers, to other users. So if you look on the left, that is a server. It's a nice tall tower. We call that a cabinet. And then on the right, excuse me, it's a personal computer. That one happens to be a Macintosh. And so you can see that right off the bat, there's 2 major differences. One comes with a monitor. The other is really just a rack of hardware. So a regular desktop computer can be turned into a server by adding appropriate software. So a computer connected to a home network can be designated as a file server, a print server, or both. There are differences in what we call form factor between servers and computers. Even, we saw the cabinet versus the small object on the right, but even down to the main board. And this is where we plug in all those hardware components. So you saw that from our first class where we talked about the different hardware components with the computer. On the right is the PC mainboard, and on the left is a server mainboard. And so both have a mainboard, but you can see definitely on the left there, that is a much more complex combination of plugs, of transistors. You could see that here, if you see my mouse, there's actually a slot for 2 different processors, where on your PCs, you're going to have a slot for 1 processor, 1 CPU. Those processors are also going to have a different form factor. So you're not going to plug a server processor into a PC mainboard. Also, you could see that we've got different slots here for memory, where we've got a couple slots here on our PC side. You get all those slots for the server. Servers are constructed to have a much more sustainable uptime, meaning they are running 24/7 for a year at a time without being restarted. Obviously, when you have to update the software on a server, you are often required to reboot the server, but you'll know using a PC that you have to restart that PC all the time. In fact, at work, all of our our people at work, they use PCs, so they use the Windows PC. And one of the troubleshooting steps we walk them through when they're having issues, if we just can't resolve it using software, is to restart the computer. So you definitely have to restart that computer more often. This is a picture of a PC CPU versus a server CPU. So PC on the left, server on the right. Uh-oh, Jay, you don't know how Kahoot works. We're gonna do one more Kahoot. So ask me a question when we get to Kahoot, okay? So servers have much more powerful processors. You see they look a little different. You've got this one kind of has a kind of a cloud or a beveled edge, where this one looks flat. So they kind of look different. Obviously, they're called different things. When you go to shop for a PC, you can see the CPU that's on board the PC. They call it Core i7. But when you go to shop for servers, you're looking at a Xeon processor. You'll see that in the specs. Another difference in servers is their RAM is more sophisticated than a PC. It has an extra component of memory dedicated just for error checking and correcting. So if you look at your PC RAM, you have 8 chips here on that, we call it DIMM, or on that card. And then when you look at the server RAM, you can see that there's 9 chips. And so it is the difference of being a non-error correcting, checking and correcting RAM, or error checking, correcting RAM, where it has that extra chip. Now, ECC RAM, Giovanni says, server RAM is more money. That is absolutely correct. That is another difference between servers and PC. Servers are thousands and thousands of dollars. It's not all because of the RAM. All right, so ECC RAM corrects memory corruption due to random, what they call bit flips, so preventing system crashes and data corruption. And this is important when you cannot afford system failures when using the computer 24/7 for an extended period. Think of banking. Think of a cloud server farm. So any of these systems that we need up 24/7, thank goodness we have that extra capability to handle error checking and correcting, because these other 8 chips, they're dedicated to that processing that we talked about in our hardware segment, where the machine code is passing data across to the PC for calculations and passing it back out, whether to commit it to the hard drive or display it on the screen, that sort of thing. Here are 3 types of servers, and this is again a form factor for servers. You will see blade servers, and you can see each one of these vertical gray pieces is called a blade. And it's easy to kind of slide that blade in and out. So if you have to do a swap of something, see what this guy's doing here. He's got that server component that he's either taking out or putting in, but that is a blade setup there. And then we have rack servers, which is essentially just it looks like a chest of drawers, right? You just have server, 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 server. And then here we have something called a tower server. So those are our 3 different servers that if you go into a server room, you could run into any one of those. This one looks like it has a glass front that covers up the different servers, and so you can kind of see them functioning a bit with their various lights and types of servers. What have we got? We've got many different types of servers. So common ones that you are probably using: web server, email server. You could be using at work a database server, proxy server, FTP, you got it. File transfer server. So that's where you're storing your files. Potentially what we call a secure copy or SSH over to other file servers that are dedicated just to storing files. So in most cases, server computers are located in data centers, and that's what we're looking at here in the picture. Oh, Giovanni's running a Plex server. How about that? So this is a data center. This is one of those cabinets with the glass front where you can see what's happening behind the glass front, but nicely everything's tucked away in that cabinet. I kid you not, we have had issues at past companies I've worked for where somebody shut down an entire server because they tripped over the power cord. So it's nice when everything's tucked away in a cabinet. You don't have to risk that scenario. So let's take a look at this data center. What are some of the conditions that a data center must have? High internet connectivity. So a lot of data centers are close to, we call it T1 in communications, which is just a very big fiber connection to telecom. And when you request internet connectivity from the cable company, you're getting a very small portion of a T line. But when you are a server farm, such as we're seeing here, they actually can plug into a much larger set of fiber resources than we actually have running to our homes. Air conditioning. These babies are hot. They run hot. We talked about the hardware on your computer and how that CPU generates a lot of heat processing those electrical currents. Well, servers, I mean, it's tons of CPUs. You've got multiple CPUs on each server. So very cold server rooms and a lot of airflow, good airflow. Similar to the way the fan blows over the heatsink on your own PC, we have to have that sort of airflow and cold air moving through a server room. Backup electrical power, so important. Obviously, if you see the backup power setup for different servers or even buildings that organizations live in, it's just tons of batteries, batteries, stacks and stacks of batteries. Fire protection. Again, we talked about how it's very hot. What if something sparks? We're dealing with electricity, we're dealing with heat. You are going to want to douse that with fire protection. Security. Got to have security. To get into a server room, only a few people have authorized access to enter in a server room. And in some cases, only a few people actually have permission to enter a floor in a building that a server room is on. That was the case at one of the companies I worked at. Maintenance. We talked about how access to the servers is limited. So we need somebody to maintain it. And so that is a component of what you purchase when you choose to host your server in on a data center. Server farm, data center, same thing. Databases. We have this in a question. Databases are collections of data usually organized under a schema and stored in a format that is efficient for storing and retrieving the data. So schema really is a collection of similar data. In the database that I work in, we have a schema that is dedicated just to HR related data. We've got a schema that's related just to accounts payable data. So that's a schema, groups things together. So one strength of computers is their ability to store and process information, that information being stored in databases. Typically, computers, they can't see all of the data. We just pick and choose certain columns certain rows that we want to look at. And so that functionality, that data storage takes place in databases. Two different types of databases, relational and non-relational. Let's take a look at that a little closer. So this is a relational database. And so you often hear the term SQL database in relation to database. So this is a common structure of a SQL relational database. It's a classic database structure that you see, and you manipulate the data. All right, so SQL databases are table-based, or what we call tabular. And you can see that in the image there on the screen. Your tables are a collection of similar information, and then that entirety of all those different tables are what we group in a schema. You can see that we have a table that is dedicated just to storing employee information, a table that is dedicated just to storing manager information, and then a table is dedicated to storing departmental information. And so I use SQL to go and interact with querying the data out of the system. I might be able to insert data into a table or delete data from a table. So that's how SQL works in conjunction with the database. And you can see that in this situation, we've got in the employee table, the employee's name, and then we have for their manager association, just an ID. And so the relationship between the employee table and the manager table is this ID. So when we want to see who is Mr. Xavier's manager, we have to know that the value stored here matches a value stored here. And in order to see who the manager is, we have to know that that name is stored in the name field. So these tables are a combination of columns, or what we call fields, and rows, which are your records or your data that you can work with. Similarly, if I want to know what department an employee works for, I can't just query the employee table. First, I have to know where department information is stored. And in this case, department information is actually connected to the manager. So if I want to find out what department Mr. Xavier is in, first I have to find out who his manager is, see which department that is, and then I can retrieve the name information or the description from the department table. And as you progress into the SQL class, we actually go through and we talk about how to set up those queries and what we call relationships to return the information that you want. Now, SQL databases are very common. And so there's a lot of support out there in the world if you're writing SQL. Tons and tons of websites, training. And there's even consultant firms where that's what they specialize in. They specialize in working with SQL databases and developing SQL code and assist companies with very large scale deployments. Non-relational databases, or what we call NoSQL, or not only SQL. Different structures of non-relational databases are the document structure, graph structure, key and value structure, or wide column. So the traits of a NoSQL database are that it has a dynamic schema structure for unstructured data. And usually that data is either a key / value pair combination stored in a document form, or a graph database, or what we call wide column, where the columns are dynamic, as opposed to what we saw in the tables. Going back here, where your table, you have a finite number of columns that you can work with. If you want to add a column, you have to add that column to the entire table. It's a very formal process, but with this wide column format, you can add columns on the fly, depending on if the data demands it or not. NoSQL databases, they offer more flexibility in terms of storage options. You can spread your data across many machines more easily than a SQL database. And you unfortunately have to rely on community support, and limited outside experts are available for setting up and deploying your large-scale NoSQL deployments. But the world of big data has really been the impetus for the growth in this area. So we may see that change in the future. Alzar, did you have a question?
Oh yeah. Did you say that the non-SQL offers more flexibility in storage, or was it the same?
It
Okay,
does.
making sure.
Of storing your data, which, now we're talking about how we're structuring stored data, in terms of this tabular format is, these little arrows represent relationships. So the relationships, you have to be very implicit in when you're setting up a table, where the relationships are, where the table is to find the related data from another table. Whereas when you're storing something in a document format, it is much easier to add different, I want to show you one of these tabs, because it actually is, it shows us how, this thing drives me bonkers. All right, let's see. Hmm. All right, so let's get rid of you. Here is a tabular representation of data. So in this particular example, we have different users that we store in one table and their hobbies in another table. So say you set up an account at Michael's or Joann Fabrics or Hobby Lobby. You have an account, and then you tell them, these are all my hobbies. And so obviously they're going to know that when they try to sell you stuff, that they're going to try to sell you items that are in line, pardon me, with your hobbies. And you can see that for every record in this hobbies table, we have a reference, a user ID reference back to the user in this table. And so we have this partition of data. Now for the same user, when we look at that stored in a NoSQL database, essentially this entire block of detail, this key will say here, first name, colon, and then this green value or this orange value, that's how that data is stored. So a lot more concise. And then we have a series of tools that can go through and interrogate that information and bring back results similarly to how we do in SQL. So I thought that was a nice example of the difference between SQL and NoSQL. Often with databases, SQL databases, we refer to something called a database management system. So when we are in the vernacular, we're saying, oh, I work on databases, we actually really mean we're working with the database management system. So the database are the sets of tables and objects, but the system is really a combination of programs like MySQL or PostgreSQL, Oracle, which they're designed to complete tasks of storing, updating, caching, deleting, and other types of data manipulation in the database. So when we see the term API here, we really are just referring to a combination of code that knows when I want to interact with a database from an app, or when I'm a user wanting to interact with the database, it's that API that knows how to do that, or those tools that know how to do that. So that DBMS then reaches and manipulates into that, database and manipulates that data, queries it, whatnot, however is needed. So some Fun facts about database management systems: they actually create the complex structure required for the data storage. They transform entered data to conform to the data structures. They create a security system and enforce that security within the system. They allow multiple users to access the data within a computer network environment. Obviously, similar to how multiple people access a web page, and then all of the data they're entering and retrieving from that web page is stored in a common area. Similar to how a database kind of works, is you have multiple user endpoints that can log into that database and pull data from it, enter data into it. I work on a team that works with the same database. We can all connect using different what we call sessions. The DBMS performs backup and data recovery procedures to ensure the safety of the data. It enforces integrity rules to maintain data consistency, and it provides access to the data via utility programs and from programming language interfaces. I showed you the other night the tool that I use when we were talking about software, IDE, that sort of thing. And that's what I use to actually interact with my database tables and other objects like functions and packages. We learned about that as well. What are different types of database management systems? So you can see them listed there. They're common ones. You may have heard of Oracle or Access, Microsoft Access, SQL Server, and you have other ones listed there as well. These are some of the most popular. So you'll see these in the news per se. All right, big data. You saw a question on the quiz with big data. What the heck is big data? It's data that contains greater variety, arriving in increased volumes and with ever higher velocity, or what we call the 3 Vs. Essentially, it's larger, more complex data sets, especially from new data sources. And new data sources are popping up all the time. Data sets are so voluminous that traditional data processing software just cannot manage them. But these massive volumes of data can be used to address business problems, create forecasts, create estimates that you just simply wouldn't have been able to perform, to achieve with databases as they were, or collections of data as they were. Big data is kind of a hot topic, especially when you consider the Internet of Things, right? These data collection points that are all over the place, whether it's sensors collecting information on how inflated your tires are, or who passed through the toll booth at a plaza. Different types of data. It's constantly being gobbled up, and we can actually derive meaning out of that data, but you really have to be well trained to be able to pull meaningful information out of data. And we refer to those folks as data scientists. All right, so I am going to just cover a couple more slides. Oh, we also have a job title, Big Data Engineer. That is nice too, nice title there. A couple more slides for big data, and then we're gonna go to our break. So big data, take a look at the screen, and the images essentially show you what type of data is passing through each of these channels in a minute on the internet. And take a closer look, compare the values from 2019 to 2020. Obviously, 2020 was an unprecedented year in virtual usage. So we're passing a lot of data back and forth because everybody was at home. But you're also going to see growth in data just because we just discussed data sources. Users are popping up all the time. Data sources are being created. New users are entering the market all the time. See, we had a big jump with Google. See, when 3.8 to 4.1 million. Facebook, 1 million to 1 point, or let me see. Yep, 1.3, sorry, old eyes. And uh, instant message through Apple, that's 18 million to 19 million. Yeah, Netflix, big jump. I know I was binging like a mad person. There are pros and cons to big data. Obviously, the pros: better decision making, increased productivity, reduced costs, improved customer service, fraud detection, increased revenue, increased agility, greater innovation. I mean, that's really what everybody is looking for. Let's get some innovation out of all this data that we've collected and faster time to market. But the cons of big data, I mean, you were gathering data from every angle, and you can't really control quality of that data, right? It's just a raw collection. You really are challenged in finding talent to work with big data. Like I said, very specialized set of skills. There's a cultural change in terms of using big data. Obviously, we have um, a lot of folks that don't like all their data being collected. Compliance issues. What type of data are you collecting? Are you storing it responsibly? There are cybersecurity risks in collecting all of that data. There's rapid change and everything. One collection of data points 1 month may not be relevant the next month, depending on how that different subject changes, or if there's emerging technology or disrupting technology associated with that data collection. There's a lot of hardware necessary. So we looked at that server room, tons of server space necessary for collecting that data. And in that, there's higher costs. And then there's difficulty integrating legacy systems with perhaps new systems that you bring aboard to store and work with your big data. All right, we are at the break point. When we come back, I want you to provide me some thoughts on big data. So think about that over the next 15 minutes. Come back to me at 8:01 p.m. Eastern, and I will see you. All right. So we left off talking about big data, and we talked about one of the issues with big data is actually cultural at heart. This is a funny joke that kind of represents that, how people are feeling about big data and gathering data, all that data in general. It's, my wife asked me why I was speaking so softly at home. I told her I was afraid Mark Zuckerberg was listening. She laughed, I laughed, Alexa laughed, Siri laughed, Cortana laughed. And that's how people feel. They feel like all of our devices are listening to us, and they are. And Google was in the news a couple years ago because it came to be known that their Google devices were listening to input without us realizing it, right? They were listening to our conversations, and they said, well, that is to make them better at interpreting what you're saying, right? But everybody was very up in arms about learning that about their device, their Google device. All right, I am going to ask you about what you felt was the what were some of the main ideas of big data, or what do you think big data is that kind of in the world? Give me any thoughts on big data. Sabrina. A lot of people feel that way. All right, let's take a look. All right, yes, the 3 V's, massive amount of information. It is data, songs, it is videos, it is, like I said, tire pressure, it is gas mileage. All of our cars are connected, our microwaves are connected, our vacuums are connected. Huge collection of digital information. Exactly. They are big. That is right. Yep, input from sensors. That's right. I mean, we're just talking about things we use. I mean, there's weather sensors out there. Scientists are using weather sensors to learn about everything from, hurricanes. There's sensors on mountains to try and detect earthquakes, that sort of thing. Great answers. Great answers. Clouds. Let's move into the cloud component. If ever there was a marketing jackpot, it was calling this next batch of technology the cloud. It's just very catchy, and everybody seems to think it's this grand concept, but it is really, like we saw, a data center of servers. Just you don't have to own all of that hardware to use the cloud or use those servers. So common misconception is that there is no cloud, it's just somebody else's computer. Kind of loosely the idea. The cloud has a lot of services available to somebody that really just having somebody else's computer with is not apt. So cloud computing allows us to pool our resources. It's on demand. It has broad access. It has elasticity, and it is measured. So elasticity, it adapts. You need to use more resources, it adapts to your usage. Don't need to use that much in terms of the available resources, then your needs, it compensates. It's measured. Again, you pay for what you use, right? Reminds me of those stores where they have the dispensers for like coffee beans or legumes, or even if you go to a candy store, how you can put a bag at the bottom and just kind of open up the mouth of it, and it just pours a whole bunch of contents into your bag. You pour in a little bit and you use that much, you pay for that much. You pour in a whole lot and you pay for that much. So cloud computing is possible because of a technology called virtualization. And virtualization allows for the creation of a simulated digital-only virtual computer machine that behaves as if it were a physical computer with its own hardware. So we're presenting this structure that we typically historically would associate with a physical computer and an operating system and applications, where we've containerized that virtually. And when you access that container, it's like you're logging into a server or an operating system or an application. All right, the cloud refers to servers that are accessed over the internet and the software and the databases that run on those servers. Cloud servers are located in data centers. We saw that. They're all over the world. And by using cloud computing, users and companies don't have to manage their own physical servers themselves or run software applications on their own machines. And so in my line of work, we actually went virtual with servers, but had a system remain as a, we called it on-premise, or it was hardware. It was hardware that we had to purchase, that we had to maintain, as opposed to when we virtualized different servers, we were able to have another company provide their hardware and their resources for maintaining the hardware, at least, and the physical server, though, was our responsibility to maintain. So this is an example, kind of a maybe Photoshop, but it's kind of the idea of another type of server room where they just have the different cabinets all lined up. That's what you see, cabinet after cabinet after cabinet. There are different types of clouds. Oh, what is Vic? What is virtualization? Is this what you mean, Vic? Virtualization. I see a suggestion there, remote desktop. That is an excellent thought there. If you've ever used remote desktop, you're actually accessing a computer. It could be another hardware computer, but it could be a virtual computer. So virtualization is that we set up through software, we set up a structure, and that program structure is set up so that if we load, say, an operating system within that structure, it thinks that it's being installed on a physical computer. So everything's there to kind of mimic that physical computer environment, but we're actually doing that through software. So no hardware is needed. The hardware that's actually involved are these very powerful servers that we don't have to own. Whereas if you were thinking of it in terms of a PC where you're installing an operating system or an application, that you do have to purchase. Similarly, companies have had to purchase physical servers and stick them somewhere on premise. But in this case, these servers actually store those soft structures so that we can install an operating system or applications on that operating system. Does that help? Like, okay, great. So types of clouds. We have public clouds, private clouds, hybrid clouds, and community clouds. So public clouds, those are typically, they have massive amounts of available space, which is easily scaled, which means when we talk about scalability, say you are on a website that it allows 500 people, and then the next day your product that you're selling is in the news, and now you have 200,000 people logging into your website. To quickly scale to that kind of usage, if you're on the cloud, it can adjust to that change in usage, meaning it can allot more space within the storage for that website to handle the creation of additional user accounts. It can allocate more RAM to process requests to and from the server that hosts that website. So that's what's nice about the cloud, is there's scalability to quickly adjust to demand. And also, if you need to expand your company in that you have a certain, to put it simply, say you are a McDonald's and you have another franchise of McDonald's that you need to bring up. Obviously, you're going to take whatever data policies and storage policies that you use for every other franchise, and you're going to set them up again for this new franchise. And so you have the ability to then do that quickly and scale that quickly. One day you may set up one franchise and need to duplicate your structure, but then the next day you may have 5 franchises opening up and you need to set up the IT components for all 5 of those. So that scalability allows us to replicate or expand as needed. So examples of public cloud, Amazon Web Services, or AWS, Azure. We talked about Google Cloud, that is a public cloud. Pinterest uses a public cloud. Private clouds usually reside behind a firewall and are utilized by a single organization. So there is a lot of intellectual property that that company may be trying to keep secure, but within that organization, they do want the applications and the services that are available as part of the cloud. They want that readily available to all that are authorized within that organization. Banks would be a good example of a private cloud. Facebook actually is on a private cloud. Hybrid cloud, it is a combination of both public clouds and private clouds, and the two platforms interact seamlessly. That one is recommended for businesses balancing big data analytics with strict data privacy regulations. And a company that uses that is Walmart. They use that configuration. And then community cloud is more collaborative, multi-tenant platform used by several separate, distinct organizations to share the same applications. And so users are typically operating within the same industry or field. Think government. We have all these uh, arms of the government, right? We have all these agencies and departments, but the government kind of has this overall model of interacting with their data and their resources. Another industry that uses that model, it's highly collaborative, is the educational industry, educational institutions, a lot of collaboration, especially in higher education. I don't know if community cloud is synonymous as multi-cloud. I challenge you to Google that and let me know if those terms are the same. Oh, I see. VC, you asked what company uses a hybrid cloud. For that example, Walmart. Walmart uses a hybrid cloud. And it really is a preference. Obviously in here, they're saying we recommend this cloud type if your business needs, tight regulatory requirements, got to keep that data contained, or if you are working with collaboration, recommend these other types of clouds. But it really is the company's preference. So it says Facebook is using a private cloud. Instagram was using a public cloud. And then once they were purchased by Facebook, they brought them into their private cloud. Obviously, the availability to use Instagram didn't change, right? But this is just a way for an organization to store their resources, to manage their server footprint, that sort of thing. Yeah, so I see hybrid cloud is like a combination of apples and pears, where multi-cloud is like a combination of different types of apples. So would you say multi-cloud is really just, I hit Google that. And Google uses I don't know what Google uses, if they're a public cloud or private cloud or hybrid cloud. I know Google Cloud is public, but I don't know about Google, the company, how their server footprint, cloud footprint is managed. An example of community cloud is, I've seen governments. So say our federal government in the US, there's the IRS, there's the Department of Transportation. These different arms of the government do very different things, but collectively they're all operating under this governmental kind of standard operating system. And there is collaboration in terms of their sharing information back and forth. So who is in the cloud business? If you take a look there, you see that the leaders in the cloud market, and this of course was recorded fourth quarter 2020. These services included this, we'll talk about this, platform as a service and infrastructure as a service. I'll tell you what those mean in just a second. So when we say that in terms of this graph, it is including any type of cloud service as opposed to maybe just storage. If you're thinking in storage terms, this is a whole type of delivery. Well, that's an interesting definition for multi-cloud, that different cloud providers. The left cloud doesn't know what the right cloud is doing, that sort of thing. Could be useful in, privatized research, research and development sort of thing. You want to store everything on the same server, so to speak. These are our leaders in the cloud market. So AWS, Amazon Web Services, Azure, Google Cloud. Now, You'll notice down at the bottom is Oracle Cloud. Oracle was late to get into the cloud game. Vikram, what do you mean by this stat for public cloud? The stuff that we're looking at, are these statistics for public cloud only, or this one actually says that it's a combination of both, what I'm assuming is public and private, because it does say as well as hosted private cloud services. So I'm gonna think this is either type, whatever this company offers, right? They may specialize in both private and public. I imagine they're not limiting themselves to just public or just private. So I mentioned infrastructure as a service, platform as a service. You can see there at the top, we also have SaaS, software as a service. So that's how you pronounce that. PASS is PaaS. Let's look at the differences between storing a server on site, so your company, and you're thinking about the best way to utilize your dollars, your technology dollars, based on what you need. And of course, if you hire people in-house, right, you got to think about paying them for their salary, but also their benefits. So you have to think about the space solutions that you have for having an on-site server. We looked at the server rooms and we talked about the fact that they need a lot of air conditioning and fire suppression and things like that. What if your facility can't really support that type of those rigid conditions that you need for big servers? So let's take a look at what each of these solutions represents. So on-site, you're responsible for everything. You are responsible for setting up the networks, the servers, the storage. You have to support the operating system. You have to maintain data storage, the applications. All right. The next slide is pizza as a service. Thank you, Barney. But in the IaaS column, you can see that what you are responsible for versus what the provider, the service provider manages, is cut in half. And so infrastructure as a service is a model where a company rents the servers and storage they need from a cloud provider. So they don't have to worry about hiring all the experts in-house. All of those experts actually are working for the provider. All of the hardware is at the provider. They have all the conditions they need to store, to manage the server in-house. And then what happens in an IaaS contract is, as the person, the customer of the contract, they basically use that cloud infrastructure to build their applications, right? They are renting the infrastructure. When you move to platform as a service, in this model, companies don't pay for hosted applications. Instead, they pay for the things that they need to build their own applications. And that includes the development tools, the infrastructure, the operating system. So you see they're renting most of the resources, whether that's server storage or managing the operating system on the server, middleware even. So things that live in middleware are things like provisioning. So how you are accessing the different applications and software and servers in your footprint, in your technology footprint. So PaaS vendors offer everything necessary for building an application. Talked about the development tools, the infrastructure, the operating system. They offer that over the internet. And it can be compared to renting all the tools and equipment necessary for building a house instead of renting the house itself. Software as a service, SaaS, instead of users installing an application on the device, SaaS applications are hosted on cloud servers. The users access them over the internet. SaaS is like renting a house. The landlord maintains the house, but the tenant mostly gets to use it as if they own it. Software as a service. I don't know if anybody has used ServiceNow. That is a big software as a service provider. All right, Barney, there you go, I'm speaking to you. Pizza as a service. So here is that breakdown in a little different light, right? So if you need to eat pizza and your responsibility for every part of that at home, you are responsible for getting the cheese, the tomato sauce, the toppings, making the pizza dough, the oven, the fire in the oven, or the electricity and the gas, the soda that you're going to drink, and setting up the dining table. But if you choose to go infrastructure as a service, then essentially what you are renting is the items to kind of set up the foundation for that pizza, and then you kind of add in the tools that you need to eat that pizza. So the vendor is going to be making the pizza for you, but then your table, your soda, your heat, your fire. So I'm thinking if you go to the grocery store and you buy a frozen pizza, pizza infrastructure as a service. Now, pizza platform as a service, everything is done for you except for providing the dining table and the sort and the soda. So in this case, they're creating the pizza, they're baking it, and essentially they could deliver it. You could take it away, but it arrives to you hot and ready to eat. You just need to find something to put it on and drink. Software as a service is really the whole kit and caboodle. So this is where you are maybe going to a restaurant. They're doing everything. They're cooking the pizza. They're providing you the table. They bring you your soda. So software as a service, you really don't have to worry about managing anything. So you can see that software is very light touch, very limited need for you to manage any components of that process. Whereas if you go infrastructure as a service, you still have quite a bit of responsibility. It's just the resources that are kind of the foundation of a computing ecosystem are taken care of by a vendor virtually. Giovanni, I see that you use ServiceNow, right? Software as a service. Okay. Tell me how you feel. We've talked about a lot. We're about to Kahoot. So if that doesn't make you a green happy face, I don't know. I have a question about middleware. What do I mean when I talk about middleware? Middleware, like I said, it could be provisioning. And that is just essentially, it sits in the middle of all your applications in a sense that if you, or single sign-on is another version of middleware where you're not accessing a specific server, you're not accessing a specific application. This is technology that allows you to integrate with all of those application server items in your ecosystem. So single sign-on, you've got 10 different applications, but the single sign-on technology says, all right, I'm going to store your name and I'm going to store your username and I'm going to store your password. And then depending on whatever application you try to access out of those 10, you're going to use the same username and password for all of them. And the way each one of those 10 applications know who you are is because they're going to come back to me sitting in the middle, and I'm going to say, oh, that's, Gretchen. And this is her, these are her access credentials. And I'm going to let them know that you are authenticated and able to log into that system and that communication takes place, but you're not logging in and using a SSO application. If you're an administrator, that's a different story, but you don't go to work and first log into SSO, as it's called, single sign-on. You actually just try to access the application. So that single sign-on is behind the scenes. It's also what we consider the back end. VMware. Yeah. Yeah. VMware. That sits in the middleware space. It's one of those applications that it sets up the structure for virtualization. So it's not a server per se, it's not an application per se. It is one of those tools. Let's see, is it going to show the responses? Driving me nuts, this thing. All right, we got some worried faces. I love the heart. Some worried faces. Feel free to ping me if you're having, frustration or confusion. You're going to see these. I like this one. It's like a fashion smiley faces. Feel free to ping me if you need any help with the topics, or you want me to repeat anything. Obviously, the first pass on some of these concepts it's a lot to take in. Always with technology, it does help to hear it repeated. It does help to see it applied. I'm one of those learners that unless I see something in practical application, I have a hard time visualizing what's happening, especially in technology, where somebody could sit there and explain to me how they coded something, but until I look at the code, how that code is applied, it's not sinking in. So just let me know. That's not uncommon to feel that way. And I am here for you if you have any questions, anything I can answer. Okay. Next topic, web browsers and security. What the heck are we talking about? We're talking about web browsers, and I mentioned and talk about HTTP, hypertext transfer protocol, cyber attacks, encryption and decryption, HTTPS, very similar to point number 2, VPN, virtual private network, and API. So we touched on API earlier. We saw that that was kind of an in-between kind of set of program solutions to help you communicate with other tools and applications and servers. So we'll take a look at what that is involved with that in a second. All right, everybody, we are back. I have shared my screen. Let me know if you cannot see it. All right, home stretch. So the web browsers, HTTP, cyber attacks, encryption, decryption, HTTPS, VPN, and APIs. First things first, web browsers. Mosaic was the first web browser. And you can see, not beautiful, right? Very basic. It was released in 1994. I can't imagine how many folks out there were not even born yet. These are the most popular web browsers. Internet Explorer was decommed to become Microsoft Edge recently, but Google Chrome is the most popular. And then some of these other browsers, they are geared more towards like Opera here. It's geared more towards secure browsing. You see, this is Safari. That's Apple's web browser that they deliver on their computers. And then Firefox. This is a modern web browser. You can see that the presentation of the web pages is separated out in what we call tabs along the top. Obviously, you are using a browser right now to interact with us. If you are using Kahoot, you're doing that through a browser. If you're accessing the LMS, you're doing that through a browser. Go ahead and let me know on the screen, what browser are you using yourself? I got some Chrome users, Firefox. Safari, Google, Firefox. I have to say that in my normal business day, I try to stick with Chrome because it's most capable with all the technology I'm using, but I do use an application that only works in Internet Explorer, despite the fact that Internet Explorer is essentially no more. It's still available for you to use, but Microsoft wants you to transition to using Edge. Okay, we've got one person using Netscape. That's been around for a while. And somebody using Brave. You're not using Netscape. Funny joke. There is a browser out there that we had to real quick start using at my last organization because of the web security that has been put in place. This one specifically, we had to put on Apple machines. It's a browser called SeaMonkey, and I had never heard of SeaMonkey, but it was just one of those browsers that actually happened to support the technology that my application requires for Macintosh, for Mac. So that was a lesson. I don't know if anybody else has heard of SeaMonkey. All right, web browsers. Web browsers use what we call HTML, and it's the standard markup language for web pages. So with HTML, you create your websites. It's pretty easy to learn. Let's take a look at some of the components of HTML. You might have heard of that phrasing, HTML. HTML utilizes other different types of coding in order to present to you the web page experience that you guys are used to. So the different components to presenting a web page are HTML, what we call cascading style sheets, and you often have JavaScripting that is embedded in your web page to provide the more dazzling things that you commonly see on web pages. So straight shooting, HTML really is structure. It is not enough. It doesn't have enough capability to actually really do much. So you're thinking in terms of what is the text on the screen? Is there an image on the screen? So these are really just screen components. To actually make the web page more beautiful, you add style using cascading style sheets, and that establishes the style, the look and feel for the entire website. So it also provides some consistency through the many different pages that you may hit on a website. And then there's JavaScript, and JavaScript, it allows you to assign behavior to the page. And what we mean by that is some of the transitions that you see on web pages. If you ever go to a web page and it shows you one picture, I'm thinking of like car web pages, right? You go to the Porsche website, right? And it shows you the Porsche, and then the screen moves and it shows you another Porsche. It just like keeps showing you Porsches. And it's just a very, very cruel website. So if you want to stylize your web page, you use CSS. And to make the web page dynamic, you use JavaScript, also denoted as JS. And if you've heard of Java, JavaScript and Java are not the same. Here's kind of a different representation of HTML, CSS, and JavaScript. So HTML is your structure, right? They're the bones of your web page. Then if you want to give that web page some style, dress it up in a nice sweater, brush its hair, put on some nice shoes, you assign CSS style to it. And then JavaScript, if you want that web page to do cool tricks, JavaScripting. The web uses a protocol we refer to as hypertext transfer protocol. It's what you see up in your address bar when you are typing in the URL in a more formal sense. So obviously, when we type in URLs, we may abbreviate it. We may not even have to enter in www, but that HTTP at the beginning stands for Hypertext Transfer Protocol. And that is the method that we're actually using to send application web page data across the internet. So it's an application layer protocol for distributed collaborative hypermedia information systems. And it's the foundation of data communication for the World Wide Web, where hypertext documents include hyperlinks to other resources that the user can access, for example, by a mouse click or by tapping on the screen in a web browser. So when you interact with a web page, it's the hypertext transfer protocol that knows what to either retrieve for you and bring back in the results based on your action. So your request is sent to the web server as an HTTP request, and then that server responds using that same protocol. The different types of methods of data transfer using HTTP, there's different standard commands that are used, and you can see the commands there: get, post, delete, put. And there's bits of information that are stored depending on the command that you use. You can see on the right, if I'm sending a command to a web server, you can see that that web server has a series send standard protocol for providing a response. And so as a client, by using this protocol, so you're the one at the client side using the web browser, you make a request to the web server with specific methods like get, or post, delete, put. Every request has two parts, the header and the body. Get only has a header, really doesn't have to provide body information, right? Body, if you're posting something, you have the header direction and then the body of what you're posting. But get is just a request for a web page from a server, and then the server responds with a status code. And you can see the status codes here on the right, depending on the response. If it sends a signal of 1, and this could be 101, 102, that's what the XX stands for. It's 1 and some numbers. 1XX is information, it sends back information. 2XX means success. 3XX means redirection, and 4XX means that there's a client error. 5XX means there's a server error. And then after the status code, it sends a response, which actually consists of the header and body information. Now, when you go to a web page and there's a problem accessing the web page, you may have seen before 404 errors. And that's just a real not beautiful page, black and white, that says, 404 error. And that means that there was some issue with the client that you're using. It just couldn't retrieve the information it needed. So that's why you see those funny numeric error messages. And a lot of technology uses numeric error messages, and then there's resources to help you decipher what those codes, those numbers or code combinations represent. Cookies. An HTTP cookie, which could be referred to as a web cookie, an internet cookie, a browser cookie, or just cookie. It's a small piece of data stored on your computer by the web browser while browsing a website. And they were designed to be a reliable mechanism for websites to remember stateful information, such as items added to the shopping cart in an online store, or to record the user's browsing activity, and including what buttons you might click on a web page. Obviously, when I go and I browse a store website and I've logged into that store website, I get information via email that says, hey, I saw you looking at this product, and if you're still interested, click this link. Well, it's the cookies that actually stored the fact that I looked at that product. Cookies can use to remember pieces of information that the user previously entered into form fields, such as names, address, passwords, and payment card numbers. So if you say, open up your browser, you go to the store website and you've got 3 things in your cart, you can close that browser, go, shut down the computer. Days later, open up the browser again, go to that store, and it'll know that you put those 3 items in the shopping cart. So that's what the cookie does, is it stores that type of information. Giovanni say Chrome uses the dinosaur game when the internet is down. I don't know if I've ever seen the dinosaur game. You have to tell me. I do know that when there's an error on Amazon, when there's a problem on that site, they show you the dogs of Amazon, right? Have you guys ever seen that? That's cute. Just to real quickly show you the application of cookies in the browser. This is Internet Explorer, and I just want to show you this, which is in this tool, browsing history. And this is, of course, an older browser, but it does give me a nice way to show you that in the internet options in the browsing history section, I can actually go into the settings for the data browsing history section, and I can view the files that are being stored for each web page. And this includes the cookies. So this is where it's actually storing that cookie. It's a file, and it contains all that relevant information related to my browsing. And of course, there are methods to clear that data from your computer. So always remember that your browser is going to have a method for you to be able to clear that out. Cyber attacks can happen in a few different ways. Lucy, you asked, do cookies have bad sides that affect the person's browsing? It is possible. Obviously, you don't want to go to a website that utilizes cookies maliciously, but it is possible. You can go to a website, it can put a cookie on your computer that tracks your behavior across the web, wherever you're browsing, that sort of thing. So yes, cookies can be used maliciously. Obviously, we want to interact with organizations that only have the best intentions, but you have to be careful. Great question. Now, cyber attacks can come from a few different angles. We have we have to be aware of physical security of our computers. An example, I talked about having special access authorization to get into server rooms. Locking up your laptop when you leave the office. If you leave your laptop behind, put it in a locked drawer. Software security. To prevent cyber attacks through software, you need to be testing for and fixing flaws in your applications that could grant attackers to unwanted levels of access in your system. And then there's network security, right? Who can actually get into your network? Who can access your systems? And we have ways of putting preventative measures in place to prevent people from accessing, whether it's websites or databases, file servers, that sort of thing. The way access works, and we saw this on the quiz, the authentication, access and authentication process is threefold. First, there's the identification component. So when you go to a web page or you're trying to log into a tool within your company, first things first, you provide the information for who you are, my username, my password, or some code, whatever, that is unique to you. And so the identification portion says, who are you, right? And then the authentication component says, is this person the person they claim to be? And so they're authenticating who you are. Once they validate that you are who you are, and that can be through a series of your secret password, or you also have gone to websites where they've asked you the challenge questions. All right. I know what your first car was in your first elementary school. You're who you say you are. And then authorization. Then Once you are identified and authenticated, you receive authorization, and that means you are able to perform an action, whether it's accessing a server, accessing a web page, logging into your Apple account. Phishing is the fraudulent attempt to obtain sensitive information or data, such as usernames, passwords, credit card details, and other sensitive information, obviously birth dates, addresses, that sort of thing, by impersonating you as a trustworthy entity in digital communication. So typically that's carried out as called spoofing emails. So an email that is designed to look like a valid email from some sort of entity, whether it's an email from your bank, an email from your CFO, right? You can work for a company in a department where if you get an email from the CFO, you're like, oh, I got to do this right away. The CFO is asking for it. But that email actually comes from a bad actor. You can get phishing through instant messaging and text messaging. And the phishing often, even though it looks like a normal email or message or text message, it'll have like a link or some interactive component that if you interact with it, it actually directs you to either enter personal information in a fake website, so that you think you're at the legitimate website, but you are not. You're in a completely different place. Malware is malicious software. So this particular stuff is, it can be invoked by those phishing attacks. So if you click on a link within a phishing attack, it could install, be a command to install malicious software. And some malicious software terms that you may be familiar with, watching the news: viruses, Trojans, rootkits, worms, spyware, crimeware, adware. It's all malware. And recently, an application that my company uses, that company that created that application, they were hit with ransomware where unless they provided money to the people that created the ransomware, they would not be able to access their tool. And I don't know how many companies use this tool. It is a very common tool. But malware is any software that's intentionally designed to cause damage to a computer, a server, a client, or computer network. Programs are also considered malware if they secretly act against the interests of the computer user. So we talked about, can cookies be bad cookies? Certainly, if they are used in conjunction with someone that's trying to act against you. Widely used malwares, you can see on the screen there. If you aren't expecting an email from someone, you get an email and it has links in it, don't open it. Just, if you're in doubt, contact that person another way. Hey, you sent me an email to send you my banking information. That's weird. Don't respond to that. Call them instead. Definitely, if you're getting, a lot of times I'll see emails that'll say, oh, your account is past due. And obviously, if something sounds wrong. The opposite of that is if somebody reaches out to you and it's like, oh, I know this prince from another country and he has millions of dollars, but he just needs like $5,000 to help get his money out of the bank. And if you send him the $5,000, he's going to give you $1 million. It's so easy. It's like worth it. The advice there is, don't be fooled by tempting offers like that. If the range is close and the cheese is big, be sure that it's a trap. And if things are too good to be true with random emails from strangers, be on your guard. Did Giovanni, you had an example where PayPal said that you bought an iPhone 13 Max email? I haven't gotten that email, but it sounds like something those jokers would do. SQL injection. So SQL injection is a code injection technique that's used to attack data-driven applications in which malicious SQL statements are inserted into an entry field for execution. So you go to a web page, there are fields that you type into. Well, the hacker goes to that web page, sees that there's interactive fields they can type into, and what they do is they put malicious code in there. And the entry point that they have to actually activate that code is poor coding in the background of that web page, right? The person developing that web page left exploits where this person could go in and actually run code that the web page was not designed to work with. So the SQL injection, it exploits the security, and then that code could delete information, could change information. It gives that bad actor the ability to access records, database information as bad as high of an access level as an administrator. So SQL injection is mostly known as an attack vector for websites, but it can be used to attack any type of SQL database. So it doesn't have to be a website. It could be just an application that uses SQL database. And let's see, what else can I tell you? Another thing people can do with it, say it's a bank balance, say it's a website that allows you into your bank. If there was a vulnerability for a SQL injection, somebody could possibly change your balance. Here's a visual of SQL injection, kind of conceptually what might be happening. So you've got a car racing along. That car actually has the command, in this case, to drop a database table. Obviously, if you lose an entire table out of your database, chances are that table, depending on what it is, could cripple the entire database. But this particular car, in a sense, is fooling speed traps and clears out your record. And in this case, clears out an entire table. So it's kind of a visual of what SQL injection kind of does to your database, just plows right through and destroys everything. Cross-site scripting, or we see that referred to as XSS. It's a type of security vulnerability typically found in web applications, and it enables attackers to inject client-side scripts into web pages viewed by other users. A cross-site scripting vulnerability may be used by attackers to bypass access controls, such as the same origin policy. So let's take a look at that. So you are here, right? We've got the perpetrator. They identified that a website has a vulnerability that enables cross-site scripting. They inject their code into the website with a script that actually acts to steal what we call session cookies. So as the victim, you are trying to access a website. Well, this perpetrator says, all right, the next guy that tries to access this website, I'm going to impersonate him. I'm going to gather up all of his identification information, and I'm going to use that instead to do whatever I need to do. So the perpetrator picks up that session cookie, and we talked about cookies storing identifying information. And then for each visit to the website, that malicious script is activated. So depending on what the cookie is storing, they could be viewing all your activity. And then all the information that that cookie is storing is also passed on to the visitor. I mean, the perpetrator. Perpetrator. Cyber attacks also can include cross-site request forgery. So this one is essentially the victims logging in to, say, their bank. The bank then assigns the victim what we call a validation token. So yes, I know who you are, and I validated that you are authorized. And then what happens is that hacker is kind of sitting in between that victim and the communication back and forth between the bank website. So in this case, the hacker sends a forged request that's actually disguised as legitimate communication from the bank. And the forged request is actually executed by the bank, believing that is actually a request from this victim who was authorized. So cross-site request forgery, also known as one-click attack or session writing and abbreviated as CSRF, sometimes pronounced as CSRF or XSRF, is a type of malicious exploit of a website where unauthorized commands are submitted from a user that the web application trusts. And there are many ways in which a malicious website can transmit such commands, specially crafted image tags, hidden forms, JavaScript, XML, HTTP requests. They can all work without the user even knowing. So how can you prevent CSRF? You don't want to put yourself in a vulnerable situation. So the phishing, right, that can actually set you up for allowing the hacker to access your machine. Antivirus tools have web security components to them that are helpful. You know, and obviously trying to protect yourself from phishing. So be very aware of the types of communications that are coming in. I get text messages with just links to random web pages. Don't click those. That's happening to you. Don't click those. Yeah, Ikram gave some good suggestions. Clean your browser history, use antivirus, internet security software, and be vigilant with what you click on and who you respond to in terms of messages, emails, that sort of thing. Encryption, decryption. Encryption is a way of scrambling data so that only authorized parties can understand the information. Oh no, Stephen, it happened to you. Ooh. In technical terms, it is the process of converting plain text, the original bytes, texts, images, etc., to ciphertext, which is the encrypted text. There's an example there on the screen where we can type into a document, hello. The encryption process then scrambles that, and this is what somebody looking at ciphered text would see. So we'll talk about kind of the mechanics of what's happening there and how things are encrypted and decrypted in a second. Encryption requires the use of an encryption key that is a set of mathematical values known only by the sender and the recipient of the encrypted message. This is an example of a Caesar cipher. And the way this works is if I'm encrypting the word John, the Caesar cipher says, all right, for all these letters, ABC through Z, I'm going to shift the alphabet by 3 spaces. So everywhere you see in this word a letter represented on the top row, I'm actually going to send you the letter on the bottom row. So for the name John, if on the top row I see J, I'm actually going to move over to the right 3 spaces. So 1, 2, 3. Let's do this differently. Just look at the top row. This bottom is already shifted 3 spaces. So if I'm going to send somebody the equivalent of J, if you go over 1, 2, 3, you can see that 3 spaces over is M. And so that's what the equivalent is down here in the cipher solution, right? So O, same thing, go over 1, 2, 3, that's actually R. That's why you see this relationship here. So O to R. Encryption can go either way. So using this particular model where in this example, it's +3. So I go over 1, 2, 3. If I say instead, encrypt Mike, but use a Caesar cipher of -3, using this top row and the -3, so you're going to ignore this bottom row, using the -3 conversion, how would you represent Mike? Go ahead and do that. And then I'm going to show the pair deck where you can enter that into the screen. So I'm curious what you guys get. You can put it here if you want. I'm just going to open a pair deck so you can put it there as well. I see one person already put their answer in there. All right, I see a bunch of people have gotten to take a look at that. So I'm going to open up Pear Deck here. Mike, what did you get? All right, I see that we've got NJLE, I've got JFHB, PLNH, a couple of different JLEK. Let's take a look at that previous slide. Let's talk about what's happening there. So in this example, it actually shows you the +3 conversion right below. So where we've got the word John, if I were to go from J over 3, 1, 2, 3, I get M. And so that's the equivalent there, J to M, O to R, H to K, N to Q. So instead of going to the right +3, what happens if for the word Mike, we go -3? So -3 from M is 1, 2, 3, J. -3 from I is 1, 2, 3, F. -3 from K is J, I, H. And -3 from E is D, C, B. So I got JFHB. Let me know if you feel strongly that it should be something else. Yeah, this is kind of this kind of throws it off a little bit if you have the bottom row here, because that's really only the conversion for +3. So you just got to look at it as counting left or right based on this top row. It makes I feel it's a little clearer, but this was the basic cipher from the beginning of time. And nowadays, we talked about algorithms in a previous class. That is how we cipher. Let's take a look at how ciphers have come, how encryption has come. So these are the sizes that you see in terms of encryption keys. So if you look at an encryption key size, somebody says, all right, well, encryption is 128 bit. Encryption is 256 bit. If we go down to a single bit of encryption, that means out of the possible combinations to use to decrypt message, you have 2. And this follows our two factor of 2 we see with our I'm drawing a blank here, binary. That's what it's called. With our binary power of 2 calculations, where the first bit had 2 options, and the second bit had 4 options, the fourth bit had 16 options, possible combinations for a binary number. Similar here, it's something to the power of 2. So where we have 128 bit key, there is a possibility of 128 to the second power. So when you look over here to the right, how much time does it take to find one of those possible, you can see 3.4 times 10 to the 30th power there. How many years does it take to resolve that? That's going to be a lot of years. And definitely, if you go up to 256, you're just, it goes up exponentially. So that's how encryption keys work. The higher the encryption, the greater the number of possible combinations that can be used to encrypt. And when somebody tries to crack encryption, they have to find the one key solution that decrypts your data. And so this time to crack is actually, there are computers that bad actors use just to run through a series of possible decryption solutions. And they're just hitting sites over and over and over to try to get access using whatever code combination will work. So when you guys use passwords on websites and they're basic passwords, like say you go to Dunkin' Donuts and your password is donut123. That's very basic. It's going to be easy for somebody to guess. And it's very short. So it's kind of the same concept, is the fewer number of combinations that you present to decrypt something, it's the easier it's gonna be to figure out what the solution is. Decryption encryption works in this process. So you have what's considered a public key and a private key. And these are known as key pairs. The public keys can be known to others, one person, multiple people. Essentially, if you have the public key, you're not decrypting anything, but you have the algorithm that is needed to encrypt your data. Private keys are only used by the recipient to decrypt the data. So if you're sending me information and we want to keep that information secure, that information is going to stay encrypted until I use my private key to decrypt it. The generation of key pairs depends on the cryptographic algorithms, which are based on mathematical problems termed one-way functions. And effective security requires keeping the private keys private, and the private key can be openly distributed. The public key can be openly distributed without compromising security, right? So it doesn't matter who has the knowledge to encrypt something. Nothing's going to decrypt that unless you have the private key. And that person, that recipient that issued the public key is the only one, or should be the only one, with that private key. And you can see it's asymmetric, so it only goes one way. I can't send you something encrypted by a private key and have you decrypt it with public key. It doesn't work. It doesn't work in that direction. Other types of security, this one has to do with HTTP security. This is HTTPS. Now, obviously, you see that right here in my address bar, the Pear Deck tool that I'm using. I have to log into that. Pear Deck is using security, and it's transferring any data transfer in a secure fashion. So Hypertext Transfer Protocol Secure, HTTPS, is an extension of HTTP. And it uses for secure communication over a computer. It is used for secure communication over a computer network and is widely used on the internet. In HTTPS, the communication protocol is encrypted using what we call either transport layer security or the older version of that technology, which is secure sockets layer security. So this protocol can be referred to as HTTP over TLS or HTTP over SSL. And if I go through back to my old friend, Internet Explorer, I just want to show you that you can configure, at least on this browser, it's an old browser, you can configure what security protocol this browser actually uses. Let me see if I can find it in this list. Yeah. So a while back, we had to go through Internet Explorer and we had to uncheck SSL because it was aging out. And we had to say, okay, if you're a browser, you're only going to use this TLS protocol because SSL was not as secure. I looked for this feature in Chrome and I didn't see it. So I'm going to assume Chrome only allows TLS as a security protocol. All right. SSL encryption, or HTTPS, the way that transfer of data works is you've got your client side. The client side generates a session key, we call it 243, and encrypts the request with the server's public key. So the client side says, hello, the server sends back that public key. The information is sent back to the server, and the server says, okay, I see that public key. My private key reads what's come over in the session and knows how to decrypt it, and now allows for an exchange of encrypted data between the two, what we call nodes, or what you might consider a computer. And then any communication between the client and the server is encrypted with that session key 243. VPN. There's companies out there where they offer VPN software. And essentially, it stands for Virtual Private Network. And a VPN provides privacy, anonymity, and security to users by creating a private network connection across a public network connection. So I'm using Wi-Fi, but the connection on that public Wi-Fi, I've actually privatized that with a virtual network so that nobody can see the data that I'm passing back and forth. That's what that VPN does. Kind of, it cloaks what you're doing. Without using a VPN, your connection, your identity, digital identity can be traced on servers and also on the internet, and your location can be detected. So if you are on a using corporate intranet, a lot of times you have to connect to a VPN in order to access that internet of private data. And that is VPN. Sometimes if you're on the corporate website, you don't have to use VPN, but if you're remote and trying to access the corporate network, then you do have to use VPN to actually start requesting and sending information back and forth. Ikram says VPN servers are super slow. It can be true. It depends on how much resource is provided to that VPN server. Obviously, you can be at home, your network is working fine, but your VPN connection goes down. Free ones are very slow, I'm sure. All right, so basically, in this particular image, they're showing you what happens if you don't have VPN enabled. So whoever owns the internet router here, like a coffee shop or a hotel, that router can read all the traffic that passes through the connection. Your computer is going to patch into that coffee shop router, and then your hacker computer is also going to be connected to that router. So there's a vulnerability there for that hacker to pick up the data that you're sending back and forth. So if you're at the airport using the airport Wi-Fi, if you're using unsecured Wi-Fi, anybody nearby can read your traffic as it passes through the air. So that router is the vulnerability. And then all the data sent between the router and the ISP, or that internet service provider. That service provider is the gateway to the internet. And that service provider can also read all of the traffic that passes through it. And ultimately, we saw the other night where we were tracing our connection. So all of those connection points that we saw on that trace website, all of our data, if we weren't on a VPN, all of our data could be read by each one of those servers as they're receiving of packets, requests, and moving them on, pushing them on. With the VPN connection, you see it kind of acts as a tunnel. It sets up this tunneling system where all of your data that you're transmitting back and forth is sent directly to a VPN server. And then even though you require the router to utilize a connection and you require the internet service provider, that gateway to the internet, you have this tunnel, this virtual tunnel that you've set up so that all of the information that you're passing back and forth is not visible to any of these nodes along the way. How does one get the VPN? Have you ever heard of NordVPN? That is a VPN that I hear advertised, and I think that is just a really combination of like a client-side software and maybe their infrastructure in place. Oh, Stephen knows NordVPN. To set a VPN on your phone or computer, at least with my company's VPN that I use, it is just a client. So I actually this company that I work for uses Cisco AnyConnect. And then they, of course, have the administrators have control over the VPN settings and whatnot. But NordVPN, that's private. That would be something that you own. And then the client side that you work with, you install on your phone or your computer. See, a lot of suggestions for different VPNs. Again, do your research. Don't trust everyone. APIs. So I mentioned APIs a couple of times. Application programming interface. And an API is a computing interface that defines interactions between multiple software or mixed hardware, software, intermediacies. It defines the kinds of calls or requests that can be made and how to make them, the data formats that should be used, the conventions to follow. It can also provide extension mechanisms so that users can extend functionality in various ways and to varying degrees. So in layman's terms, you want to be able to quickly use a toolbar in your browser, right? You go to a website and they say, Yahoo comes to mind, right? They're like, enable the Yahoo toolbar to quickly use Yahoo tools in your web browser. So you don't have to know how to get your browser to interact with the Yahoo toolbar. There's programming behind the scenes that knows how to work between the browser and the Yahoo toolbar. And those APIs, those communication APIs or those interface APIs kind of have all that knowledge. So you don't have to say, all right, toolbar, when I put in something to search on the screen, it should also be put in the toolbar here. That API automatically knows how those two disparate things, the browser and the toolbar, are related. In terms of what I use APIs for, I have code that I write, and I have data sets that I work with. If I call an API, say I have somebody's first name, last name, phone number, if I code it the long way, I have to know exactly where the table is that data goes into and what I have to do to record the entry of that information into the table. But if I use an API, I just have to say, hey, API that creates employee information, here's some data, and it knows exactly what tables to put it in and how to record that record was created on a certain day and who created the record. And so all this user, or what we consider that metadata that we talked about in a previous class, that API knows how to assign all that other information. And I don't even have to worry about that. It makes my job as a programmer much, much easier. An API can be custom. So I like utilizing APIs that are created by the company of the products that I use. But APIs can be created from scratch for custom reasons that are specific to a component or based on an industry standard to ensure interoperability. So before there was the Yahoo toolbar that worked seamlessly with Chrome, there had to come some standard for browser toolbars to work with the Chrome browser. And that API was developed to try out to allow that back and forth. That's the synergy. Through information hiding, APIs enable modular programming, allowing users to use the interface independently of the implementation. So that's another way of using APIs. I don't necessarily have to go into my application to load data into the database, right? So it's not where I have to fill out a form of employee information and submit that form data. I can actually use a different interface completely. I can use a spreadsheet, and I just use an API that knows how to take that spreadsheet data and move it into the database. I'm bypassing that application level completely by just using kind of a data source to data destination setup, and that's all capable through an API. APIs can be used as an intermediary between so many different things. So how does your iPhone understand what your iRobot Vacuum is doing an API. An API knows how to move that data between devices. It can take sensor data and move that into an application on your mobile, an enterprise application. If somebody is trying to unlock their car from their smartphone, it's the API that is connecting those disparate items and allowing you to gain functionality between the two. All right. So we did our full Kahoot. So we're not doing Kahoot again. So you had all your questions. But tell me, out of the emoticons on the screen, tell me how you're feeling at the end of that. Okay. So we have smiley faces. Oh no, we've got a frowny face. We've got some people with sunglasses on that are just too cool for school. I'm concerned about you guys, flat faces and frowny faces. I want to hear more about what you're troubled by and how I can help you, because obviously I want to get you guys up here in the blue spot. It could take some questions and answers, and I'm going to give you guys an opportunity to ask your questions coming up here in a second. But thank you for your feedback, though. That is very helpful. And I don't want you to feel stranded, just lost in misunderstanding or confusion or anything like that. All right. On this slide, write the most important thing you learned from today. Your choice, whatever you think. All right. Cookies are not always sweet. Very nice. Maintaining proper security when working with database. Yep. We talked about the injection, SQL injection. Big data, APIs, CPN and big data. Cookies can be used to steal information from my systems. Obviously, those websites that are presenting the managed cookies, they're doing things, based on a code, right? They're following standards where you actually get to pick and choose what types of cookies are stored on your system. But obviously, not everybody. Not everybody has standards. All right, the 3 V's of authentication, the big data, and don't use easy passwords. Yes, don't use easy passwords. Use a different password for every website. There are products out there that are essentially password stores or key stores where, depending on where you go, whatever website you go to, that software knows what your credentials are for that software. That's very helpful. That's very helpful in the sense that your passwords are stored someplace separate than obviously that data that you're trying to access, right? So Target is a store here that they had a breach, right? And if I use the same username and password for Target, for Walmart, for the grocery store, for my bank, then when Target had their breach and they captured the username and password information from Target, they could then start trying all these other websites to log in as me, and that happens. So those password storage products, they're very helpful because then you don't have to remember 800 different passwords. You kind of have this repository. Cloud, encryption, decryption, malware. Nice. Cloud is not in the air. Very good. Way to take it away. All right. So I am going to open it up for questions. We're obviously at the end of the content for the class, but if you have questions, let me know. Shoot. I see a question, what is cloud? And cloud is actually just I would say it's kind of a marketing term for um, service providers who offer you, whether it's infrastructure or platform or software resources that you don't have to manage yourself, right? The content for the cloud, what we think in terms of what's stored in the cloud, is stored on a server somewhere, is no different in storage terms than having a server at your company or having a server in your office at home. But cloud computing is really the hardware and the availability, flexibility that is provided by engaging with a provider that offers cloud services. Does that help? For cloud computing, do we need Python? That is a good question. I would say depending on what you're doing, right? If you're developing an application using Python, yes, you will need Python. There are software as a solution setups where all of the tools that you need to code in Python, down to whether it's a database that you're working with or a web server that you're working, whatever you need when you're coding with Python, that's all provided as part of that cloud service. But then you could have that infrastructure as a service where you own the Python IDE, and you own the, we'll say, database that you're interacting with Python. More Python or Linux. Again, Linux, so an operating system you're talking about, it depends on how much of that as a service level you're utilizing. So infrastructure as a service, you may own your server. And so obviously Linux is that operating system on that server. You own the server, you manage the operating system. But if you go to a platform as a service, that organization that's providing that PaaS service, they own the server, they own the operating system, and thus they manage that for you. And you don't have to have a Linux expert, because when you have an issue with your operating system, you put a ticket in, goes out to a technician at that company, and they say, oh, what's happening? How can I help? What are main things you should remember moving on from computer fundamentals that we generally use in our work day to day? Gosh, everything. I'm not joking. I would say, obviously, if you're not in your work day to day, if you're not working on servers, know the components of the server, right? You don't have to be able to, call from memory some of the different types of hardware that we discussed, nor some of the software components. Obviously, in your work day to day, you're using software, and you know that there's different types of software. So an operating system versus an application. And day to day, obviously, the internet, the different types of servers, you don't have to know specifically, oh, I'm using a DNS server and it's assigning me, it's the phone book of the internet, that sort of thing. You just want to more be sensitive to the fact that when you are using the internet, you're vulnerable, make good choices. You want to be diligent in protecting your information. And as a steward of your company, you want to be diligent about protecting your information from that company. Are you going to be having to think about converting binary day to day? No. But I would say in your day to day, personally, the thing that I worry about the most is, data security and my own personal security versus, not my own personal security, but my personal data security, as well as the data security that I'm privy to as part of my role, and being a good steward of that. Welcome. But depending on what you do day to day, what's most important to remember is really based on what you do day to day. And essentially, as you go through the classes, that front end, back end distinction, you're going to be working on the back end component, right? So it's good to keep in mind that, you know, all of the efforts you're making on the back end, the end result is somebody is seeing that front end, somebody is seeing the presentation, somebody is going through that experience, right? And so everything we do on the back end as technologists, whether it's development or pulling data, it's about the end result. It's about the user and how we can improve their experience, right? Can we get them better data? Can we get them more accurate data? Can we make an application more efficient? Can we make wait times shorter? So that's what we do. Anything else? Other questions? I'm here all night. I don't see anything. I will see you in SQL class. It's not the end. And I wish you the best of luck through your cohort. You guys are fantastic. And I enjoy this so much. So wherever you are, stay safe, be happy, and I will see you soon.